Can virtual labs replace real physics labs? A research-based analysis of digital versus physical learning environments. So can a computer simulation replace a real physics lab? Some studies are actually saying yes, but is that true or is it just theory? When you look at the research, a lot of studies suggest that virtual labs can improve student performance in physics. So on the surface, it looks like simulations might actually be better. Multiple peer-reviewed studies suggest virtual labs can enhance students' performance in physics education. Performance gains. Simulations show measurable improvements in test scores and conceptual understanding. Digital promise. Interactive platforms offer accessible, scalable alternatives to traditional laboratory settings. Sounds good. But that's not the full story. Because when you examine the research more critically, the picture becomes more nuanced than initial claims suggest. So, what did I do? I went through multiple research studies comparing virtual labs and physical labs. I focused on three major things: performance metrics, conceptual understanding, and student engagement. Performance metrics, in the sense that I looked at studies that measure test scores and assessment results, studies that focus on conceptual understanding in terms of the depth of physics knowledge, and then of course studies that also looked at their participation and if this treatment also improved their motivation. So after doing all of that, I found out something, that most of these studies follow a simple structure, which is that um, most of the studies tested physical labs versus virtual labs, and in each of or in majority of the studies, one group of students uses physical labs while the other group uses virtual labs, and then at the end of the treatment their results are compared. So results like their motivation levels, their engagement levels, participation, and so on and so forth. Where did that lead us? The results showed that across many of these studies, there's actually no significant difference between the two. Virtual labs and physical labs perform almost the same. Both methods improved understanding, that is conceptual understanding, and that both studies, majority of these studies proved that both virtual labs and physical labs effectively build foundational physics knowledge and conceptual frameworks. Again, these studies also found that students in both environments showed similar improvements in standardized assessments and course grades, meaning that when they compared their tests or assessment scores, the difference in the level of performance was not very far apart. And then in terms of student engagement, interactive elements in both formats increased motivation and active participation in learning, meaning that in both environments, that is virtual labs and physical labs, students' motivation and participation also improved, and there was very little difference between the two. So one key insight we have to point out is that the question is no longer which one works, but rather where would you use each of them. Although they don't actually work the same way, I believe I should point that out first. See, virtual labs are flexible, they are easy to repeat, and great for visualizing abstract concepts. Aside from the fact that they are also less expensive compared to physical labs. Physical labs, on the other hand, um, they help students develop hands-on skills like real science process skills and real tactile experience with this equipment in the laboratory. They also help students. They also equip students with practical experiences, real life experiences, and helps them develop um, their science process skills and problem solving skills. And then in addition, it also helps them to create experiences that virtual labs might not be able to replicate yet. So um imagine a student learning electric circuits. You as a physics teacher, you introduce virtual labs in the classroom. You find out that students will be able to test these connections depending on whatever experiment you give to them. They'll be able to test these connections instantly and see what happens. So it takes away some of the usual problems that would normally occur in a physical lab. Little problems like connecting the wires together, needing a sellotape, and so on and so forth. We'll get back to that. So, but in a real lab, you know that they actually connect the wires, and most of the time they are not perfect. So they make mistakes and fix them. Sometimes not as instant as in a virtual lab where they don't necessarily or physically have to connect the wires. They just have to click a button or a switch on their computer or PC, and it does that for them. So that physical interaction that should have built their um, tactile experience or level of understanding is not there. So it takes that away from them, which is why we say they both have their advantages and their disadvantages. So the real question, like I said, is not which one is better. The better question would be when should you use either of the two? And we have already seen that the best results actually come from combining both, not just using one and refusing to use the other because of its limitations. Um, So, in summary, using virtual labs for understanding and physical labs for experience would help your classroom, your physics classroom, to function a lot better and faster. So, and this is important, especially for schools with limited resources. You don't need a perfect lab setup to teach physics effectively. All you just need is um, to just make do with what you have in a physical lab and then augment it or integrate a virtual lab with your lesson. So, thank you for watching. And if you're working on a research project or a school assignment and you're not sure what approach to use, please comment research and I'll send you a sample guide to help you. Thank you.